So I want to ask you a question today. It is a question that sounds very simple. It sounds like a question a 5-year-old child would ask his mother. The question is this: why is the night sky dark? Now you are going to laugh at me. You are going to say, Professor Feynman, that is a stupid question. You are going to say it is dark because the sun has gone down. The earth has turned around and the sun is on the other side, and so there is no light. And I am going to tell you that you are wrong. Well, you are partially right. That explains why it is not daytime. That explains why we are in the shadow of the earth. But it does not explain why the sky itself is black. Think about it, If you go out into the deep ocean and you look at the water, it is dark. But if you look at the sun, it is bright. Now imagine the universe. For hundreds of years, the astronomers and the philosophers believed something very specific about our universe. They believed two things. First, they believed the universe is infinite. It goes on forever in every direction, left, right, up, down. It never ends. Second, they believed that the universe is filled with stars more or less evenly, like raisins in a pudding. Sure, they clump together in galaxies, but on the big scale, they are sprinkled everywhere. So we have an infinite universe, and we have an infinite number of stars. Now, I want you to do a little experiment in your head. I want you to imagine you're standing in the middle of a forest, a very thick forest. Everywhere you look, you see trees. Now, if the forest is small, you can look between the tree trunks and you can see the sky outside and you can see the gaps. But suppose the forest is not small. Suppose the forest is infinite. Suppose the woods go on forever and ever. Now look horizontally. Look straight ahead. Your line of sight hits a tree trunk. Now move your eye a tiny bit to the right. You look past that first tree, but because the forest goes on forever, eventually, your line of sight hits another tree trunk, further back. Move your eye again. You miss the first tree. You miss the second tree, but 10 miles away, you hit a third tree. If the forest is truly infinite, then no matter where you look, you must eventually hit a tree. There are no gaps. The entire horizon is made of wood. It is a solid wall of trees. Do you see the geometry? It is unavoidable. Now I want you to take that forest, and I want you to replace the white tree trunks with bright yellow stars. Look at the night sky. Pick a spot, any spot. A dark patch between the constellation of Orion and the Big Dipper. It looks black. But why is it black? If the universe is infinite, then if you look at that dark spot, your line of sight goes out into space. It goes past the moon. It goes past the planets. It goes past the local stars. But if you keep going, eventually you must hit a star. If the universe is infinite, every single line of sight from your eye must end on the surface of a burning star. Every single point in the sky should be filled with light. You should not see any black. You should not see any dark patches. The entire dome of the night sky should be a solid sheet of light. It should be glowing with the same brightness as the surface of the sun. This is not just a guess. This is a mathematical certainty based on the assumptions we made. If the universe is infinite and static, the night sky should be blindingly white. It should be so bright that it would boil the oceans. It should be so bright that life on Earth would be impossible. But you look up and what do you see? You see darkness. You see a few tiny pinpricks of light and a whole lot of nothing. This contradiction is called Olbers Paradox. It is named after Heinrich Olbers, who talked about it in the year 1823. But it is a problem that goes back much further. It is a problem that worried Kepler. It is a problem that worried Halley. It is a terrible problem because it tells us that one of our fundamental assumptions about the universe is wrong. Nature is telling us something. She is shouting at us. She is saying, look at the dark. The dark means something. The dark tells us that the universe cannot be infinite and old and static all at the same time. Now you might sit there and you might try to wiggle out of it. You might say, well, Professor, maybe the stars far away are dimmer. Maybe the light gets tired. Maybe the light fades out before it gets to us. We call this the inverse square law. We know this law. If you move a light twice as far away, it looks 1/4 as bright. So you say, clearly, the distant stars are just too dim to see it. And I say to you, no, that does not save you. That does not solve the problem. Let me explain why with a little bit of geometry. Imagine we draw a shell around the Earth like the skin of an onion, a big sphere of space. Let us say this shell is 1 billion miles away, and let us say there are 10 stars in this shell. They give us a certain amount of light. Now let us go out twice as far, 2 billion miles away. We draw a second shell. Because the stars are twice as far away, each individual star is 4 times dimmer. That is true. But because the shell is twice as big away, it has 4 times the surface area, so it holds 4 times as many stars. You see what happens? The stars are 4 times dimmer, but there are 4 times as many of them. 4 times 1/4 equals 1. The total amount of light from the second shell is exactly the same as the total amount of light from the first shell. And this works for the third shell, and the fourth shell, and the millionth shell. Each layer of the universe adds the exact same amount of light to our sky. And if the universe is infinite, then we have an infinite number of layers. And we add up an infinite amount of light. So the dimming does not matter. The geometry cancels it out. So we are stuck. We are really stuck. We have a logical proof that the sky should be on fire. And we have the observation that the sky is black. This means that something in our idea of the universe is broken. Is the universe not infinite? Does it have an edge? Is the universe empty? Is there dust blocking the light? Or is it something much more strange, something to do with time itself? To find the answer, we have to stop looking at the stars and we have to start thinking about the history of the universe. We have to realize that looking out into space is exactly the same thing as looking back in time, and that is where the secret of the dark sky is hiding. Now I look at your faces and I see that you are not satisfied. You are sitting there and you are shaking your heads and you are thinking to yourselves, Professor Feynman is trying to pull a fast one on us. You are thinking, sure, if I look at a forest, the trees block my view, but stars are not trees. Stars are the lights. And we all know from our own experience that lights get dimmer when they move away. If I hold a candle right in front of your nose, it is bright. It hurts your eyes. But if I take that candle and I walk a mile away, you cannot even see it. It becomes invisible. So you are thinking that the stars very far away are just too faint to matter. You think they are so dim that they do not add up to anything. And that sounds like common sense. But I have to tell you that in physics, common sense is often the enemy of the truth. So let us not guess. Let us not use our intuition. Let us calculate. Let us do the arithmetic. We have a law in physics called the inverse square law. It is a very precise law that tells us exactly how light fades with distance. It says that if you double the distance, the light does not go down by half, it goes down by a factor of 4. 2 multiplied by 2 is 4. If you triple the distance, the light goes down by a factor of 9. 3 multiplied by 3 is 9. So mathematically, we say the brightness is proportional to 1 divided by the distance squared. So you say, see, I told you, the stars far away are incredibly dim. A star that is 10 times farther away is 100 times dimmer. So the background stars must be invisible. But you are forgetting the other half of the story. You are forgetting that space is 3-dimensional. You are forgetting that as we look further out, the volume of space gets bigger. I want you to imagine that we are building a model of the universe using shells, like the layers of an onion. We put the Earth in the center. Now imagine a shell of space that is exactly 1 unit thick, and it is at a certain distance. Let us call this distance r. In this shell, there are a certain number of stars. Let us say there are 1,000 stars. Now let us go out to a second shell. This shell is at distance 2r. It is twice as far away. Now we ask two questions. Question 1. How bright is the average star in this second shell? Well, we use our inverse square law. Since the distance is double, the brightness is 1 divided by 2 squared. That is 1/4. So the stars are 4 times dimmer. Question 2. How many stars are in this second shell? This is just geometry. The surface area of a sphere is 4 multiplied by pi, multiplied by the radius squared. If you double the radius, the area does not double. The area quadruples. 2 squared is 4. So the second shell is 4 times bigger than the first shell. If the stars are scattered evenly through space, then the second shell must contain 4 times as many stars. Now look at what happens when we combine these two facts. We have 4 times as many stars, but each star is 1/4 as bright. What is 4 multiplied by 1/4? It is 1. The number 4 on the top cancels out the number 4 on the bottom. The dimming effect is completely destroyed by the fact that there are more stars. The total light coming from the second shell is exactly the same as the total light coming from the first shell. Now let us go out to a shell that is 10 times away. The stars are 100 times dimmer, 1/10 squared. But the shell is 100 times bigger, 10 squared. 100 multiplied by 1/100th is still 1. It is a constant. It does not matter how far away you go, and it does not matter if the shell is 1 billion light years away. And the light arriving at your eye from that shell is exactly equal to the light from the nearest shell. This is the terrible secret of the geometry. Now we have to add it all up. To find the total brightness of the night sky, we'd have to add the light from the first shell plus the light from the second shell plus the light from the third shell, and so on forever. If the universe is infinite, then we have an infinite number of shells. We are adding the number 1 plus the number 1 plus the number 1 plus the number 1 an infinite numbers of times. What is the sum of that series? It is infinity. The arithmetic tells us that the sky should not just be bright, it should be infinitely bright. Now, in the real world, stars are not points, they have a size. They block the stars behind them, so the brightness cannot go to infinity, but it will go up to the maximum possible brightness. It means that every single line of sight leaves your eye and eventually hits the surface of a star. If you look at the sky, you are looking at a wall of star surface. It means the night sky should look exactly like the surface of the sun. The average temperature of the sun is 5,000 degrees, so the temperature of the skies should be 5,000 degrees. Earth would be inside an oven. The oceans would boil away in seconds. Rocks would melt. Life would never begin. This is the conclusion of the geometry. If the universe is infinite, and if the stars go on forever, and if the universe has existed forever, then there is no escape from the heat. The fact that we are here, the fact that you are sitting in a cool room, the fact that the night is black and cold, this is proof. It is absolute proof that one of our assumptions is wrong. It is not a maybe, it is a certainty. The darkness of the night is screaming at us that the universe is not what we thought it was. So what is wrong? Is there something blocking the light? Is there a fog in space? Or is the universe not infinite? Or maybe, just maybe, the universe has not been here forever. Because if the universe had a beginning, then the light from the distant shells has not had time to get here yet. We are waiting for the mail to arrive. But before we get to the true answer, we have to talk about the answer that everyone believed for 100 years. We have to talk about the dust. So we are in a mess. We have calculated that the sky should be a blazing wall of fire, but we look up and it is dark. Now, when scientists run into a problem like this, the first thing they do is look for a simple way out. They look for something obvious that they might have missed. And for a long time, everyone thought they had found the answer. For almost 100 years, astronomers said the answer is dust. It makes perfect sense to your intuition, huh? Imagine you are driving your car in a heavy fog. Can you see the headlights of a car that is a mile away? No, you cannot. The water droplets in the air catch the light and they scatter it or they absorb it. The light stops. The fog blocks the view. We know that space is not empty. It is dirty. It is full of gas. It is full of dust clouds. It is full of junk left over from exploded stars. So the astronomers said, aha, the universe is infinite and there are infinite stars, but we cannot see the distant ones because there is dust in the way. The light hits a cloud of dust and it gets absorbed. Problem solved. Everyone can go home and sleep, but there is a catch. There is a law in physics that you can never break. You can try to cheat it, but it will always catch you in the end. It is called the law of conservation of energy. It says that energy cannot be created and it cannot be destroyed. It can only change form. So think about the photon of light leaving that distant star. It carries energy. It hits a particle of dust. You say the light stopped. Okay, but where did the energy go? It did not vanish. It went into the dust. When the dust particle absorbs the light, it gets excited, it jiggles, it gets hot. Now imagine this dust particle sitting there in space for millions and billions of years. It is constantly being bombarded by light from all sides. It is absorbing more and more energy every single second. As it absorbs energy, its temperature goes up. And what happens when things get hot? They radiate. They glow. If you take a piece of iron and you stick it in a blacksmith's forge, it starts out black. But as it absorbs the heat from the fire, it turns red. Then it turns orange. And finally, it turns white hot. And here is the rule of thermodynamics. The iron will keep getting hotter until it is exactly the same temperature as the fire around it. It reaches equilibrium. At that point, it is giving off just as much light as it is taking in. So let us go back to our dust cloud in space. If the universe is old and infinite, that dust has been sitting there for an infinite amount of time, absorbing an infinite amount of starlight. It will heat up. It will get hotter and hotter. It will stop heating up only when it glows just as bright as the stars that are shining on it. So what would you see from Earth? You would look up and you would not see the distant stars. That is true, but you would see the dust. And the dust would be glowing with the same intensity as the surface of a star. The wall of stars would simply be replaced by a wall of glowing dust. It would be like trying to block the sun with a blanket. But the blanket gets so hot that it catches fire and glows just as bright as the sun. You are still dead. You are still boiled alive. Oh, so the dust theory fails. It fails completely. It fails because you cannot hide energy. You can move it around. You can turn it from light into heat and back into light, but you cannot make it disappear. So we are back to square one. We cannot hide the light. The geometry says the light must be there. The thermodynamics says the light must be there, but the light is not there. This forces us to face a very frightening possibility. Maybe the reason we do not see the light from the infinite distance is because the light has not arrived yet. Maybe the universe is not a static thing that has been here forever. Maybe the universe has a birthday. And that leads us to the only true solution to the paradox. We have to talk about time. So I see you are still looking for a loophole. You are stubborn. That is good. To be a physicist, you have to be stubborn. You have to refuse to accept an answer until it makes sense to you. We tried the dimming of light and the math killed it. We tried the dust blocking the light and the thermodynamics killed us. So now you come to me with a new idea. You say, Professor Feynman, maybe the problem is with how the stars are arranged. In our above calculation, we assume something very specific. We assumed the stars were spread out evenly, like butter spread on bread. or like raisins in a pudding. We assumed that no matter where you go, the density of stars is roughly the same, but you look at the sky and you say that is not true. You see that stars like to cluster together. They hold hands. We have a star system like the solar system. Then we have a lot of empty space. Then we have a galaxy, which is a clump of billions of stars. Then we have a huge amount of empty space. And then we have a cluster of galaxies. Then even more empty space. So you are thinking maybe the universe is a fractal. Now, that is a fancy mathematical word, but the idea is simple. It means a pattern that repeats itself, but with more and more empty space, the larger you get. The argument goes like this. Yes, we add up the shells, but maybe as the shells get bigger and bigger, the stars get rarer and rarer. Maybe the empty parts of the universe grow faster than the full parts. If that is true, then when we do our addition of light, we are not adding 1 plus 1 plus 1. We are adding 1 plus 1 half plus 1 quarter plus 1/8. And if you know your calculus, you know that a series like that does not go to infinity. It converges. It adds up to a small finite number. If the universe is built this way, then the sky would be dark simply because most of the universe is truly empty. This is a beautiful idea. It was proposed by a man named Carl Charlier about 100 years ago. Mathematically, it works perfectly. It solves the paradox without any magic. But there is a problem. Physics is not just about writing down beautiful mathematics. Physics is about checking with Mother Nature to see if she agrees. We cannot just sit in our armchairs and guess how the universe is arranged. We have to look. So astronomers have spent the last 50 years mapping the sky. They count the galaxies, they measure where they are, they make giant three-dimensional maps of the universe. And what do they find? They find that you are right, but only at the small scales. Yes, stars clump into galaxies. Yes, galaxies clump into clusters. Yes, clusters clump into superclusters. But once you get to a certain size, once you look at a box of space that is about 300 million light years across, the clumping stops. The hierarchy ends. On the truly large scales, the universe is smooth. It is homogeneous. That is the word we use. Think of it like a bowl of porridge or oatmeal. If you put your face right down in the bowl and look with a microscope, you see lumps, you see oats, you see milk, you see empty spaces. It looks complicated and clumpy. But if you stand back 10 feet and look at the bowl, it just looks like a smooth gray paste. It looks the same everywhere. The universe is exactly like that porridge. If we look at the universe on the scale of millions of light years, it is a mess of webs and voids. But when we look at the universe on the scale of billions of light years, it is remarkably boring. It is the same everywhere. The density of stars over here is exactly the same as the density of stars over there. We call this the cosmological principle. It says that there is no special place in the universe. If you go 10 billion light years to the left, the universe looks exactly the same as it does here. And because the universe is smooth on the large scale, our fractal solution collapses. It falls apart. Because the universe is smooth, we go back to the onion shell. Since the density is the same everywhere, the giant shells far away really do contain more stars. They really do contribute just as much light as the nearby shells. The math of the fractal does not save us because the universe is not a fractal. Nature refused to take the easy way out. So look at where we stand. The stars are there. They are spread out everywhere. The light is not blocked by dust. The light does not fade away. We are running out of hiding places. We have eliminated every possibility except one. And this last possibility is the one that changes everything. We have been assuming that the universe is a stage. The stage that has been sitting there forever and the actors just move around on it. We have been assuming that the universe is eternal. But what if the stage itself was built yesterday? What if the play has not been running forever? If the universe has a beginning, then light has a speed limit, and that changes the entire calculation. Now I have to tell you something that makes us physicists look a little bit foolish. We like to think we are the smart guys. We like to think that we are the ones who use logic and mathematics to find the secrets of nature. We look down on the philosophers and the poets because they just play with words, while we play with facts. But in this particular case, the physicists were wrong and the poet was right. For hundreds of years, the greatest scientific minds in the world were banging their heads against the wall, trying to solve this paradox. Kepler could not solve it. Ali could not solve it. Olbers could not solve it. They were all stuck on the idea of the dust or the idea of the dimming light. And then, in the year 1848, a man published a little book called Eureka. This man was not a scientist. He did not have a laboratory. He did not do experiment. He was a writer of horror stories. He wrote about talking ravens and beating hearts hidden under floorboard. His name was Edgar Allan Poe. And in this strange little book, which he called a prose poem, he looked at the problem of the dark night sky and he just guessed the answer. He used his imagination. He said, "Let us suppose that the succession of stars is indeed endless. Let us suppose the universe is infinite, but let us suppose that the universe has not been here forever." He said, and I am paraphrasing here, that the only reason the sky is dark is because the distance to the invisible background stars is so immense that no ray of light from them has undoubtedly been able to reach us at all. Read that again. The light has not reached us yet. This is a profound idea. It changes the problem from a problem of space into a problem of time. Think about it like this. Imagine you are living in a city where the mail system is very slow. The postman walks on foot. Now imagine that the world was created yesterday. Today you open your mailbox. Who do you have letters from? You have letters from your neighbor next door. It only takes one day for the postman to walk from next door. But do you have a letter from Paris? Do you have a letter from Tokyo? No. The letters have been written. They are in the bag. The postman is walking. He is on his way, but he has not arrived. It takes time to travel distance. If the universe is infinite, then yes, there is a wall of stars out there. There is a shell of stars 1 billion miles away, and a shell of stars 1 trillion miles away, and a shell of stars 1 quadrillion miles away. But light has a speed limit. It travels at 186,000 miles per second. That is very fast, but it is not infinite. If the universe is only a certain age, then the light from the very distant stars simply has not had enough time to get here. We are standing in the dark, not because the stars are missing, but because the light is still on its way. Now, Poe is a poet, so he did not do the math, he just had the intuition. But a few years later, a real physicist named Lord Kelvin sat down and calculated it. He asked a simple question. How old would the universe have to be for the sky to be white? How long do we have to wait for the mail to arrive from the infinity of space? He calculated that for the sky to be fully bright, the universe would have to be hundreds of trillions of years old. It would have to be so old that the stars would have burned out and died long before the sky got bright. So here is the situation. We look out at the sky. We see the stars nearby. We look a little further. We see more stars, but eventually we hit a horizon. Not a horizon of space, a horizon of time. We can only see the stars that are close enough that their light could reach us in the time since the universe began. Beyond that distance, there might be more stars. There might be infinite stars. There might be dragons and monsters. It does not matter. We cannot see them because their light is still traveling through the dark. It will get here tomorrow, or 1,000,000 years from now, or 1,000,000,000 years from now. But right now, tonight, it has not arrived. So the sky is dark because the universe is young. It feels old to us. Billions of years seems like a long time. But compared to the time it would take to fill the sky with light, our universe is just a baby. It was born yesterday. So Poe was right. The darkness is telling us that there was a beginning. There was a moment when the clock started ticking. And this leads us to the final piece of the puzzle, the Big Bang. And the fact that the universe is not just young, but it is also moving. So now we come to the meat of the sandwich. We have eliminated the dust. We have eliminated the fading light. We have eliminated the fractal universe, and we are left with the idea from the poet Poe, the idea that the universe has a birthday. To understand why this matters, I need you to understand one specific number. It is a very famous number. It is the speed of light, 186,000 miles per second. Now, to you and me, that sounds fast. It sounds instantaneous. If I turn on the light switch, the bulb turns on immediately. Snap. Just like that. But on the scale of the universe, that speed is painfully slow. It is a crawl. It is a snail pace. Because light takes time to travel, it means that when you look at something, you're not seeing it as it is. You are seeing it as it was. When you look at the moon, you're seeing it as it was 1.3 seconds ago. When you look at the sun, you're seeing it as it was 8 minutes ago. If the sun blew up right now, we would not know about it for 8 minutes. We would be sitting here happy and warm for 8 minutes while the sun was already dead. A telescope is not just a magnifying glass. A telescope is a time machine. The further out you look, the further back in time you're seeing. Now let us put these two ideas together. Idea 1, the speed of light is finite. Idea 2, the universe is not eternal, it started. We have measured this, we have checked the expansion of the galaxies, and we have run the movie backwards. We know that the universe began roughly 13.8 billion years ago. That is a long time, but it is a finite time. It is a specific number. So imagine we are standing on the earth and we look out into the dark. We can see a star that is 1 light year away. That light left the star 1 year ago. Since the universe is 13 billion years old, that light that has had plenty of time to get here, we see that star. We can see a star that is 1 billion light years away. That light has been traveling for 1 billion years. The universe is old enough. We see that star. We can go out to 10 billion light years. We see those galaxies. But now, watch what happens. Imagine there is a star that is 100 billion light years away. It is out there. It is burning bright. It is sending out photons in every direction. But those photons have only been traveling for 13.8 billion years. They have not covered the distance yet. They are still on their way. So even if that star is blindingly bright, we cannot see it. To us, it does not exist. We are trapped in a bubble. We call this the observable universe. Draw a sphere around the earth. The radius of the sphere is determined by the age of the universe, multiplied by the speed of light. Inside this sphere, we can see the stars. Outside this sphere, there is darkness. There might be infinite stars outside. In fact, we are pretty sure there are infinite stars outside, but their light has simply not reached us. So let us go back to our forest analogy. Remember the infinite forest? We said if you look horizontally, you must hit a tree. But now we have a new rule. Imagine you woke up in the forest exactly 10 minutes ago. And imagine that light travels at the speed of a walking man. You look around, you can see the trees that are 1 minute away. You can see the trees that are 5 minutes away, but you cannot see the trees that are 20 minutes away. The light from those trees has not reached you yet. So do you see a solid wall of wood? No. You see the nearby trees, and in between them, you see gaps. You see darkness. You see the dark gaps because the forest of visible trees is not infinite. It is finite. It stops at the 10-minute mark. This is exactly why the sky is dark. When you look at the black spaces between the stars, you're looking at the history of the universe before there were stars to see. You are looking into the past. We have solved the paradox. The sky is dark because the universe is young. We simply have not been around long enough for the sky to fill up with light. Now, this is a very satisfactory answer. It explains the dark. It fits with the Big Bang. It fits with the speed of light. It accounts for about 90% of the darkness. But there is one more thing happening, one more little trick that nature is playing on us. Because the universe is not just sitting there aging. The universe is expanding. The stage is stretching. And this stretching does something very strange to the light that is already on its way to us. It steals the energy. We call this the Redshift, and it is the final nail in the coffin of the bright sky. So we have a solution. We have agreed that the reason we do not see a wall of fire is because the universe is young. The light from the edge of the universe has not arrived yet. We are trapped in a bubble of time. That is a very good answer. It accounts for most of the darkness. But nature is never that simple. She always has one more card to play. She always has one more trick up her sleeve to make things complicated. Because when we look at the galaxies, when we look at those distant stars that we can see, we notice something very strange. They are all moving away from us. Edwin Hubble discovered this in the 1920s. He found that the universe is not sitting still. It is not a static stage. The universe is expanding. It is getting bigger every single second. The space between the galaxies is stretching out. Now you have to ask yourself what happens to light when it travels through a universe that is stretching. To understand this, I want you to think about sound. You all know the sound of a train whistle or a race car going past you. When the car is coming toward you, the sound is high-pitched. When the car passes you and goes away, the sound drops to a low pitch. Roo. We call this the Doppler effect. When the source of the sound moves away, the waves get dragged out. They get longer. The distance between the crests of the wave gets bigger. And for sound, a longer wave means a deeper tone. Now, light is a wave, too. It is an electromagnetic wave. It has a frequency. It has a pitch. Blue light is like a high whistle. The waves are short and squashed together. Red light is like a low rumble. The waves are long and stretched out. So what happens when a star is moving away from us? The light waves it sends out get stretched. They get pulled longer. So a star that is actually shining with blue light will look to us like it is green. And if it moves faster, it will look yellow. And if it moves even faster, it will look red. We call this the Redshift. But in our universe, it is even weirder than that. It is not just that the star is moving through space like a race car. It is that the space itself is stretching. Imagine you draw a wavy line on a rubber band. That is your photon. That is your light. Now you pull the ends of the rubber band. You stretch the rubber. What happens to the wavy line? Does the ink disappear? No. Does the wave break? No. The wave just gets longer. The peaks get farther apart. This is exactly what is happening to the light from the distant universe. A photon leaves a star 1 billion years ago. It starts its journey as a bright, energetic piece of visible light. But as it travels for 1 billion years, the space underneath it keeps expanding. It keeps stretching. So the photon gets stretched too. Its wavelength gets longer and longer and longer. And here is the key point. Here is the physics. Longer waves carry less energy. Blue light kicks hard. Red light kicks soft. Infrared light is even weaker. Radio waves are very weak. So as the universe expands, it is literally stealing energy from the light. It is cooling the light down. So let us go back to Olbers Paradox. We said that if you look far enough away, there should be a wall of stars. But those stars are very, very far away, which means their light has been traveling for a very, very long time, which means their light has been stretched by a huge amount. So let us say there is a star way out there on the edge of the visible universe. It is shining as bright as the sun. It is sending out blinding white visible light. But by the time that light travels through billions of years of expanding space, it has been stretched so much that it is no longer visible light. It has been shifted into the infrared, or it has been shifted into microwaves or radio wave. Our eyes cannot see radio waves. Our eyes cannot see infrared. So when we look at that spot in the sky, we see darkness. The star is there, the light is hitting your eye, but your eye does not register it because the energy has been dialed down by the expansion of the universe. So we have two reasons for the dark sky. Reason number one, the universe is young, so the light has not arrived from the infinite distance. Reason number two, the universe is expanding, so the light that does arrive is too weak and too red for us to see. Now, you might ask me, Professor, which reason is the big one? Which one is the boss? Is it the age, or is it the expansion? We can calculate this. We can build a model universe that is young, but not expanding. And we can build a model universe that is old, but is expanding. And it turns out that the age is the winner. The finite age is the main reason there are gaps between the stars. The time horizon is the real culprit. But the expansion helps. It acts like a dimmer switch. It takes the light from the distant background and it fades it out. It turns the blinding white light into a soft, invisible glow. So the sky is dark because the play has not been running forever. And the sky is dark because the stage is getting bigger and the actors are running away from us. But wait, I just told you that the light gets shifted into the infrared and the microwave. I just told you that the light is still hitting us, but we cannot see it. That implies something incredible. It implies that the sky is not actually dark. It implies that if we had different eyes, if we had eyes that could see microwaves, then the sky would not be black at all. And that brings us to the final twist in the story, the invisible fire that is burning in every single part of the sky, night and day. The cosmic microwave background. So now I have to make a confession. I've spent the last hour telling you that the sky is dark because the universe is young and because the stars have not had time to fill the sky with light. And that is true. That is absolutely true if you're talking about stars. But I have also been tricking you. Because if we go back to the original argument of Heinrich Olbers, he said something very simple. He said that if you look in any direction, eventually, your line of sight must hit something. And he was right. It turns out that Olbers was right all along. The sky is not dark. The sky is actually a blazing wall of light. It is glowing everywhere. Every single point in the sky is pouring energy down onto your head right now. You just cannot see it. To understand this, you have to go back to the very beginning, the Big Bang. Now, people have a wrong idea about the Big Bang. They think it was an explosion, like a bomb going off in the middle of an empty room. They think there was a center, and the pieces flew out into the dark. That is wrong. The Big Bang was an explosion of space. It happened everywhere at once. The universe was filled with energy. It was filled with a hot soup of particles. Protons, electrons, photons, it was a plasma. And because it was hot, it glowed. Imagine the inside of a furnace. It is bright white hot. For the first 380,000 years of the universe, the entire cosmos was a fog of white hot light. Then the universe cooled down enough for the fog to clear. And at that exact moment, that light was set free. It started traveling across the universe. That light is still here. It has not gone anywhere because there is nowhere for it to go. It fills the entire universe. So when you look at the dark patch of sky between the stars, you are looking past the stars. You are looking past the galaxies. You are looking all the way back to the wall of fire from the birth of the universe. So you ask me, Professor Feynman, if I'm looking at a wall of fire, why am I not burning up? Why is the sky black? And the answer is the expansion. Remember the rubber band. Remember the redshift. That light started out as visible light. It was orange and white. It had a temperature of about 3,000 degrees Kelvin. But that light has been traveling for 13.8 billion years. And during all that time, the space has been stretching. And it has stretched a lot. The universe has expanded by a factor of roughly 1,100 since that light was released. So the wavelength of the light has been stretched by a factor of 1,100. It started as light waves that were tiny, like the size of bacteria. Now they are waves that are much longer. They are about 2 millimeters long. And what do we call light with a wavelength of 2 millimeters? We do not call it visible light. We do not call it infrared. We call it microwaves. The same stuff inside your kitchen oven that cooks your burrito. So here is the shocker. If you had eyes that could see microwaves, if you were a creature made of radio antennas instead of biological cells, you would look up at the night sky and you would not see darkness. You would see a glowing wall of light. It would be uniform. It would be everywhere. It would be exactly the same brightness in the north and the south and the east and the west. There would be no night. The entire sky is glowing with the heat of the Big Bang. We call this the cosmic microwave background. It was discovered by accident in 1964 by two guys named Penzias and Wilson. They had a big radio antenna, and they kept hearing a hiss, a static noise. They thought it was pigeon droppings on the antenna. They cleaned the droppings. The noise was still there. They pointed the antenna at the city. The noise was there. They pointed it at empty space. The noise was there. They were hearing the scream of the birth of the universe. They were listening to the ghost of the Big Bang. So Olbers Paradox is solved in the most beautiful way possible. Olbers said the sky should be bright. And nature says, yes, Olbers, you are right. The sky is bright. But nature also says, I'm going to save you from burning to death. I'm going to expand. I'm going to stretch that light until it is so weak and so low energy that you can live your life safely in the cool darkness. The darkness is just a trick of our eyes. We are blind to the real fire. So the next time you walk out at night and you look up at that beautiful black velvet sky, I want you to remember something. You are standing inside in a microwave oven. But luckily for us, the door is open and the power has been turned down very, very low. And that is why the night sky is dark. So we come to the end of our detective story. We started with a question that sounded stupid. We started with, why is the dark dark? And we found out that the answer is not simple at all. We found out that the answer takes us to the very edge of space and the very beginning of time. But I want to leave you with one final thought. A thought about what this darkness means for you and me. Because it is not just an abstract fact of astronomy. It is the reason you are alive. Think about thermodynamics. To make a machine work, to make a steam engine work, to make a car work, or to make a human being work, you need energy. But having energy is not enough. If I put you inside a furnace that is at 5,000 degrees, you have plenty of energy. You have too much energy, but you cannot do any work. You cannot think. You cannot digest your food. You simply burn up and die. To do work, you need a flow of energy. You need a hot spot, and you need a cold spot. You need a source to take energy from and a sink to dump waste energy into. The sun is our hot spot. It sends us high energy photons and yellow light. We take that energy. We use it to grow plants. We use it to move our muscles. We use it to think our thoughts. And then we take the waste heat and we radiate it out into space. But we can only do that because space is cold. We can only do that because the sky is dark. If Olbers had been right in the simple way, if the universe was infinite and static, the sky would be 5,000 degrees. There would be no cold spot. There would be nowhere to dump our heat. The energy would not flow. The universe would be stuck in a state of thermal death. Nothing would happen. Nothing would ever happen. So the fact that the universe is expanding, the fact that the universe is stretching the light and cooling it down, this is the only thing that allows the universe to wake up. The expansion of the universe is the refrigerator that keeps us from cooking. So we should be very grateful for the darkness. The darkness is the heat sink of creation. Now let us summarize what we have learned. Let us put the pieces back in the box so we can carry them home. Why is the night sky dark? It is not because the sun is down. It is not because the stars are dim. It is not because there is dust in the way. It is dark for two magnificent reasons. Reason number one, the universe is a baby. It has only been around for 13.8 billion years. The light from the infinite distance is still traveling. It is still on its way. We cannot see the forest for the trees because the light from the distant trees has not reached our eyes. Reason number two, the universe is running away. Space is expanding. It is stretching. It is taking the fiery light of the Big Bang and it is stretching it out until it becomes invisible microwaves. It is turning the fire into a ghost. So when you walk out of this lecture hall tonight and you look up at the sky, I do not want you to see a void. I do not want you to see nothing. When you look at the black spaces between the stars, I want you to realize that you are looking at the most profound thing in physics. You are looking at the timeline of the universe. The dark is not empty. The dark is the history of the Big Bang that has been quieted by the expansion of space. You are looking at the evidence that we had a beginning, and you are looking at the evidence that we are not standing still. Nature is strange. She is absurd. She creates a universe that is on fire, and then she stretches it until it looks cold and dark just so we can exist to look at it. And that, to me, is the glory of science. We ask a silly question. Why is it dark? And nature answers us with the secret of creation. Thank you very much.